Hello, welcome to the Chem 345 lab video series. My name is Akil Hamseth, and today we'll be covering liquid-liquid extraction, which is a commonly used separation method by utilizing a compound's polarities and relative solubility. So the premise of a liquid-liquid extraction is first there are two immiscible layers. One, which is usually an aqueous layer, which is a water layer that's very polar, and two, which is an organic layer that's generally non-polar. So because these two liquids are immiscible, when you put them in a separatory funnel, they will form two layers. Now these two layers can be identified based on their relative densities. For example, we know water has a density of 1, and most general organic solvents have densities less than 1, so we'll say about 0.8. So because of this, the one with the highest density will be on the bottom layer, while the one with the lower density will be on top. So here, we know our water layer will be the bottom one, and our organic layer would be the top one. So when you do your liquid-liquid extraction, sometimes you might see the formation of a third layer in between your aqueous and organic layers. This is called an emulsion, and this happens when your aqueous and organic layer are slightly miscible. So if you see an emulsion, the way to decrease that is by using brine, which is saturated sodium chloride. So effectively, you're increasing the polarity difference between your aqueous and organic layer, making the emulsion smaller. So for example, if we have 9-fluoronone and benzoic acid in our organic layer, and we want to separate them, that would be very hard without liquid-liquid extraction. So the way we use liquid-liquid extraction in order to separate these two is this hydrogen right here, the acidity of this hydrogen. So if we use a base, for example, any hydroxide, you know, acid-base reactions, it'll take a proton, and once that hydrogen was abstracted, the electrons from this bond will move over to that oxygen, creating a benzoate ion. Now, as you know, ions are charged. So since like dissolves like, the charged species will be in our aqueous layer, which is more polar, making it more stable in the polar solvent, while our 9-fluoronone, which is purely organic, will stay in our organic layer. So in the end, we'll have our 9-fluoronone in our organic layer and our benzoate in our aqueous layer. And by draining both of these layers and separating them into two different flasks, we have essentially separated both our 9-fluoronone from our benzoic acid. So the technique for liquid-liquid extraction is done in 3 parts. First, you have to shake in order to mix both of the immiscible liquids. Next, invert, and then finally release this valve in order to release the gas that's built up inside. Make sure to do that very quickly because the gas itself will start evolving quickly. Now make sure to repeat all 3 steps until there's no more pressure buildup and no more gas being formed inside your separatory funnel. And then at the end you can invert it again and your solutions will be separated again and then you can separate both of them into 2 separate flasks. So going back to our previous example with the benzoate and 9-fluoronone, we see that we have successfully separated both of them into 2 different beakers. Now our benzoate is still dissolved in our water layer, but we want our benzoic acid back. So in order to do that, we actually have to add acid to the solution. So when we add acid, this oxygen will be protonated, which will give us our benzoic acid again. Now if you remember, this is non-polar, which means it will not be dissolved in water anymore. It would actually crash out of solution as a precipitate. However, if we want to purify our 9-fluoronone, there are many different methods to do that, one of which is recrystallization, which we will cover later on. So overall, liquid-liquid extraction is a good way to separate 2 or more compounds in a solution by manipulating their chemical properties. And thank you for watching.